Bismillahirrahmanirrahim. Well, students, last time we talked about and we solved this numerical 18.1 to 18.4 of unit number 18. Today we will be solving the remaining from 8.5 to 8.9. 8.5 reads as this: half-life of a radioactive element is 10 minutes. The half-life of a radioactive element is 10 minutes. If the initial count is 368 per minute, find the time for which count rate reaches 23 counts per minute. So we have the initial count is 368 per minute. After first half-life of 10 minutes, it will be left behind 184 counts per minute. After second half-life, 184 divided by 2, 92 counts per minute. After third, it will be 46, and after fourth, it will be 23 counts per minute. So total half-lives taken is 4 half-lives. So time taken is 4 half-life. Time for the first one is 10 minutes. So time for the fourth half-life will be 40 minutes from the initial start. So this is what was supposed to be calculated. Now the next one is 18.6. This says, in an experiment to measure the half-life of a radioactive element, the following results were obtained. Now these were the results that were obtained. As per count rate per minute was 400 initially. It was 400, then it became 200 after 2 minutes, 200 after 2 minutes, then became 100 after 4 minutes, and 50 after 6 minutes, and 25 after 8 minutes. So this was the time taken. We have to plot a graph between the count rate and time in minutes and measure the value for the half-life of the element from the graph. So this is the graph that has been plotted, and this is what you had to take. You take counts on the y-axis and time taken on the x-axis, and for the first one it was 400 counts per minute. For this, after the next 2 minutes it was 200, next 4 minutes it was 100, and so on. So this is the graph. 18.7. A sample of certain radioactive element has a half-life of 1500 years. If it has an activity of 32,000 counts per hour at the present rate, then plot a graph of the activity of this sample over a period in which it will reduce to 1/16th of its present value. So 18.7. So half-life is 1500 years. Activity is 32,000 counts per hour. 32,000 counts per hour. So after first half-life, it will be 16,000 counts per hour, second half-life 8,000, third half-life 4, fourth half-life 2,000, and sample reduced to 1/16th of its value in 4 half-lives. And this is the graph that has been plotted. This is the graph that has been plotted for it. Now 18.8, which says that the half-life of a radioactive element was found to be 4,000 years. The half-life was 4,000 years. The count rate for the first 8 minutes, 8 successive hours were found to be 270, 280, 300, 310, 285, 290, and 305. Okay, 305 and 312. What does the variation in count rate show? Plot a graph between the count rates and the count. So this is the graph and that has been plotted. The answer is already given over there. So plot this graph after 1 hour, this much after 2 hours, after 3 hours, and so on. Okay, 270 was after the first hour, and second hour 280, and third, and so on. The ninth one is 18.9. This says ashes from a campfire deep in a cave show carbon-14 activity of only 1/8 the activity of fresh food. How long How long ago was that campfire made? So activity of carbon-14, 1/8. Half-life of carbon-14 is 5,730 years. Time to be taken is calculated as follows. Since activity of carbon-14 from ashes is 1/8 of fresh wood, hence 3 half-lives have elapsed. Time number of hours, use this formula, and the answer is 5,730 multiplied by 3, 17,190. So with this we come to the end of the chapter. Now I would expect you to please solve all these numericals of chapter number 18. If you have any difficulty, please talk to me on my WhatsApp number, and if you have any difficulties, please solve them. Complete the entire course by now, and now after you have completed, I will be starting with some problems or some new MCQs or some new questions that will be outside this book, so that you become really abreast with all the knowledge that you have acquired. Thank you very much, and wish you the best of luck for your exams. Khuda.